6.5. Alright, so quick warm up for 6.5. Simplify polynomials. Basically distribute what's outside to what's inside. Right? So a times 3a is 3a squared. Right? Because of the invisible ones. A times 7 is 7a. The coefficient comes before the variable. Not like terms, can't be combined. Negative 2 times 1 m times m squared. Negative 2 times 6 m1 times m1. Negative 2 times negative 1, positive 2. M1, no other variable. Can't be combined. Good. Beautiful. Visible, invisible, invisible. Alright, 4 x to the 5th. Y, because there's no other thing to multiply it by. Negative 8. Nothing to multiply the x by, nothing to multiply the y by. Oh, don't even need the one. I like to put the invisible ones, but they're not necessary. They're not necessary. Alright, so this is multiplying monomials by polynomials, or polynomials by monomials, right? So the ability to distribute and combine your like terms, right? Now, 6.5 is the other direction. We're going to factor stuff out of this and get back to this, right? So, for example, if I give you 4a squared plus 8a, it's in its simplest form. Nothing can be pulled out. Nothing can be distributed, right? It can't be combined. Factoring is to find their greatest common factor. So the greatest common factor that goes into both 4 and 8 is 4. I can take a 4 out of both of those. And the greatest common factor between a squared and a is a. I can take an a out of both terms. I can divide both terms by 4. I can divide both terms by a. If I take 4a out of this, I'm left with a, right? If I divide this by 4a, I'm left with a. And if I divide this by 4a, I'm left with a positive 2. I factored it out. I thought about what I could divide out, right? Any polynomials that cannot be factored are called prime, just like prime numbers. Prime numbers, the only factors of prime numbers are the number itself and 1. 13 is a prime number because it can only be divided by 13 and 1, period. So any factor that cannot be factored out is called prime. There are several factoring methods. The approach depends on the polynomial, of course. We will start by identifying and factoring out the greatest common factor. So 6.5 is all about finding the greatest common factor. Okay, so steps for factoring, looking for the greatest common factor. 1, identify the greatest common factor. That seems logical, right? Check the coefficients. Look and see if the coefficients have the greatest common factor. Then look at the variables. See if they have something in common. If they have a greatest common factor. A variable must be present in all terms to be a greatest common factor. So if it's a 2-term, 3-term, 4-term, 5-term, it has to be in all the terms, right? If a variable is present in all the terms, you can take the one with the smallest exponent. If your smallest exponent is a square, a squared, then that's the least and most you can take out. Right? Divide each term by the greatest common factor and leave the remaining factors in parentheses. Check your work by redistributing. Factor each polynomial, check your work by distributing. If a polynomial cannot be factored, write prime. If there's nothing in common, between the terms, it's prime. Common between 3 and 12, 3. Both can be divided by 3. They have no variables in common, so what are we left with? If we divide by 3, we're left with x plus 4. In the front, write what you divided by, what your greatest common factor is, and in parentheses, put what's left. GCF goes in the front. What's left goes inside the parentheses. Eight and 36. Both can be divided by 4. M and N, no common factors. Both can be divided by 4. So that leaves me with 2m, right? 8 divided by 4 is 2. Plus 36 divided by 4 is 9n. All I did was pull out the only thing they have in common. That's factoring. Pull out the thing they have in common. No variables in common. The greatest common factor between 6 and 27 is 3. If I divide by 3, I'm left with 2a squared plus 9. Oh, now we're adding variables. All right, 21 and negative 3. The greatest common factor is 3. Right, I can pull out a 3. And they have a variable in common. Both terms have the same variable, which means I can divide by a d on both terms. Right? So if I divide by d, that cancels the d. So if I pull out a 3d, I'm left with 7c minus 1. Just look for what they have in common. Both of these can be divided by 15. This has 2 a's, 1a, so we can take 1a out. They both have a b, so we can take a b out of both. So if I take 15ab out of both, what am I left with? This is a 1. I'm left with 1a and no b's, so I'm left with a minus 30 divided by 15, negative 30. Don't lose the negative. Is negative 2. A and B cancel. That's it. That's it. That's all I'm left with. They had a lot of stuff in common. That means I'm left with just that. Oh, look. They both have an A. If I take an A out, I'm left with B minus 1. What did I just write? Let's try that again. If I take an A out, I'm left with B minus 1. Right? And a number over itself is 1. You don't know what A is, but you know that it's over itself, so you're going to have a 1. They have no coefficients in common. They don't have no factors in common. Their variables have nothing in common. This is prime. There is nothing I can factor out. Nothing. Right? Yep. Yeah. I like being right. Anyways. Alright, 3 terms. Let's find something they all have in common. They can all be divided by 2. They all have at least one x. And they all have at least one y. So if I divide this by 2xy, I get 1, doesn't need to be there, x, right? Because these cancel and this becomes a 1. And if I divide this by 2xy, I'm left with negative y, right, because that canceled. And then if I divide this by 2xy, I'm left with positive 2. And that's it. It makes sense sometimes to write it under each one separately so that you can visualize it. You need to be able to visualize it. When you can visualize this, you don't have to write it anymore. Both of them can be, all three of them can be divided by 2. They all have at least 2 y's. Remember, the lowest exponent. So we can pull out y squared. 6 divided by 2 is 3. Y2 divided, or y4 divided by y2 is y2. 14 divided by 2 is 7. Y3 divided by y2 is y1. Negative 10 divided by 2. You hear me say negative 10? The negative is part of that 10. Don't lose that. Because it's negative 10 divided by 2, which means it's negative 5. Y2 and y2 cancel. Once you can do it in your head, you don't have to write the little thing underneath it anymore. See what I'm saying? But you need to visualize it. You need to be able to see it, because this has to apply to each one. You have to divide all 3 terms. I think this is it. Let's do this. All right. All right. They do not have a variable in common, or a coefficient in common, so the coefficients are out. All right. M cubed, M squared, M to the first. They all have at least one M, so I can pull out an M. N1, N2, N3. They all have at least one N, so I can pull out one N. What am I left with? N cancels on this one and becomes M squared on this one. Then it becomes M, N in the middle, right? Because 2 minus 1 is 1. 2 minus 1 is 1. And then we have our 5. We have the M here and the M here that cancels. And then we have N3 and N1, so we're left with N squared. And because they're alphabetical, M, Mn, N, they're in order. They're in order. All we're doing is going backwards. Instead of distributing, we're pulling it out. We're pulling it back out. Do it with me. We're pulling it back out. No? Okay. I feel that.